everyone, my name is Emre Gür. In this video, my partners and I will demonstrate our turn project. The project is implementing a fighting game on FPGA board. The game is inspired from Footsies, which is an open source fighting game. We used our logic design and Verilog knowledge that we learned through EE314 and 314 to overcome this project. Let's continue with gameplay.
Başla.
Hello everyone, my name is Arhan and I will talk about the beginning of the game, the first part. The game directly boots into the menu screen. We select the player mode with the switch 0. This is the two-player mode, the mode we play with the keypad, and the one-player mode is the mode we play with the CPU. Now I will show the two-player mode. When the first player presses any key, the countdown here appears and also appears in the screen. Let me demonstrate. 3, 2, 1, and also here. Start signal 0. This hex shows fight for the whole part, the fight duration. There is a timer here. This timer counts to 99. After 99, the game is ended in a tie. This lets show the player health. The left lets show the player 1 health, and the right lets show the player 2 health. I will also talk about the sprites. We did the sprites with mem files. We wrote a Python script, and this script converted PNG files to the mem files. And we read those files with the modules in the FPGA quarters. And that's how we show these sprites. These are all sprites. Timer is sprites, players are sprites. Yep.
Now I will talk about states that a player shows. For no input, player stays in idle position. This is our idle position. For left and right input, which is controlled by keys on FPGA board and keypad, as you can see, player goes in the desired direction. Let me show it. I take it to the automatic clock. This is for right and this is for left, as you can see. For attack, there are two options, directional and idle attack. We implemented attacks as like that. This is for idle attack and this is for directional attack. The players can take damage or block the attack by going left as other player starts attacking. If it gets hurt, his heart reduced by 1. Let me show it. I take it to there, and when I hit, his heart reduced by 1. And there are another option. If blocks can't reduce by 1. I can also show that. The blue bar reduced by 1 when if you press the left button as other players attacked. The frame numbers for attacks hit stun and block stun is as explained in project description. For this stage, we used finite state machines that we learned in lectures. We also implemented a counter in the ZFSM to obtain their frame numbers. There is also a timer that counts until 99, as you can see in here. The match is result in tie if no one wins in that time interval.
Hello everyone, I'm Altay Karagöz and I'm going to talk about 3 parts of our project, those being the hit detection system, the CPU mode, and also some visual outputs that we haven't talked about yet. So let's start with the CPU mode. So after selecting the mode from the switch and entering an input, the mode starts, and the CPU works by using a linear feedback shift register. Now this register is able to output a 16-bit random number, and the CPU uses 3 of these outputs. It uses one of them for moving left, one of them for moving right, and one of them for moving attacking. So by using this random number sequence generator, we were basically able to replicate a pseudo random pattern for the CPU to use, and it, well, hopefully by now you've already seen it in motion. Let's continue with the hit detection system. But before we talk about that, I'm first going to explain what hitboxes and hurtboxes are. So these green rectangles you see here are hurtboxes, and these red rectangles here are hitboxes. Now, in order to really detect the character states and also which character is being hit or attacked, the hit detection system looks at these boxes and basically memorizes the coordinates of these boxes, and depending on the outputs and states of these characters, it will check whether these boxes overlap, and if they do overlap, it will act accordingly. If the red boxes overlap with the green boxes, for instance, it might render an attack, or depending on the movement outputs, it might render a block, and that's how basically how our fighting game works and how the fighting actually occurs. So our game also has some quality of life parts to it that make it easier to understand, one of them being some visual outputs that help the players understand what's going on and when the game ends. As you can see here, our hex display displays who won, and also our VGA display displays who won, and you can also see how long a match took, and our LEDs indicate that the game is over when they switch on and off. Also, after using the inputs, you can go back to the menu screen. Okay, of course, the outputs depend on who wins and who loses. So, as you can see here, if the first player wins, their name is displayed, and also the hex changes accordingly. And we have an edge case as well. So, as you can see here, when our timer reaches 99, we have a tie case. This also happens if the players simultaneously reach 0 lives. So let's see the tie case. So in 4 seconds, 3, 2, 1, 0, yes. And as you can see, this is the tie case, and both players, well, the match ended in a tie. And well, to conclude, that was our project, and we were successfully able to make a FPGA based fighting game, and we had a lot of fun doing so.